Hello, welcome to our video presentation. This is Haley He and Serena Tan. In this video, we're going to share out our master project result, which is KINO, a note-taking and note-reviewing system that is designed to help computer science students self-education. Note-taking is a prevalent learning strategy that has prominent cognitive benefits when practiced properly. In the current project, we focused on exploring how CS students take notes, specifically in a context of self-regulated learning to prepare for technical interviews. Based on the research findings, we designed KINO, a cross-platform system combining a note-creating web extension and note-reviewing features on the web and on the phone. CS Technical Interview is a specialized and rigorous process that tests CS candidates' skills in solving coding problems. To prepare for the interview, students typically review the fundamental CS knowledge and do intensive problem practice on online coding platforms like LeetCode. Here is an overview of our process from problem discovery to the final design deliverables. The following presentation will be structured into these 4 stages, and I'm going to talk about each of these in more details. During the first stage of discovering, we conducted multiple exploratory research activities. We started with literature review, with a goal to explore the design opportunity space within note-taking tools, also ground our initial user research questions. As a result, we reviewed over 50 pieces of literature covering main aspects like why people take notes, different note-taking styles and strategies in various instructional environments, as well as note-taking technology design. The scientific papers help us better understand the cognitive benefits from note-taking as a learning strategy. Specifically, taking notes can help people have an immediate, deeper processing of the information. After it's encoded in mind, the notes containing a great deal of information can primarily serve as external storage, and the learning outcome will be maximized when the notes are effectively reviewed. One of such reviewing methods is self-testing. By reviewing studies about note-taking strategies, we further concluded that a successful note-taking tool should support active thinking and reflection, maximize personal annotation abilities, encourage non-linear note structures, while include adequate contextual information. Based on learnings from the literature review, we surveyed 205 college CS students with 16 questions. The goal is to learn about the target user's current note-taking habits, relevant goals, and how effective do they think their current note-taking methods are. The survey results confirmed that 79% of survey respondents do take notes for CS learning purpose, but it happens more often out of class for technical projects or interview preparation. Also, people are not very confident in their current note-taking strategies, with a mean score of 4 out of 7. Notably, 65% people suggested they use their notes less than half of the time across the semester. Given these survey findings, we decided to dive deeper into CS students' technical interview preparation experience and explore why the notes are currently underused. To realize that information goal, we did 8 semi-structured user interviews and collected note samples from our interviewees, therefore analyzed the note contents and the note structure. The interview results reveal important behavior patterns for CS students' technical interview preparation. For example, because the skills tested in technical interviews are elevated from school learnings, students need to self-regulate all the learning tasks, which are mainly problem practice focused, and to realize that they usually deploy multiple online resources, such as coding platforms, online forums, online documentations, to localize resources by company and topic filters, and understand worked problem by cross-referencing. We further conducted a competitive analysis about major online coding platforms across aspects like question amount, question categories, additional resources, and note-taking related features. The goal is to build a comprehensive picture of what learning resources are currently available. However, although practicing problems can effectively help CS students acquire the patterns, many interviewees actually mention they feel the process is tedious and stressful. By closely looking at the note samples, we identified key components in CS students' notes, such as hand-drawn diagrams, markups and annotations, real code references, and there's typically less composing, but many attachments like links and screenshots. This helps answer why the notes are currently underused, and it's because first, the notes are taken cross-media and saved in multiple platforms, which makes retrieval less convenient. And second, the notes have disorganized structures, and therefore students can easily lose the context, which in turn makes the notes harder to interpret as the time passes. We wrap up the Discover phase with 3 participatory design sessions. We invited 5 participants in total, 3 of them for 2 exploratory sessions, from where we involve our target user as informants to deeply understand their self-regulated learning context, and another 2 participants did 1 co-design session, during which users become co-designers, and we together explore design possibility for a note-taking tool that can potentially aid in technical interview preparation. During the exploratory sessions, we gave users prompts like task metrics, calendars, emojis, and markers to prompt them to reflect on their authentic experience, setting goals, scheduling tasks, and manage external resources for technical interview preparation. The first scenario is for them to plan ahead 3 weeks for an incoming technical interview, and the second is planning ahead 3 days, during which students need to make a study plan in a more granular level. The task metrics help us clarify specific learning tasks students do to prepare for the interview, which include code problem practice, mock interview, preparing for behavioral questions, and search for interview guidelines. It also helps us identify the task priority, the objectives associated with each of the tasks, and to what extent the learning outcomes can help increase students' confidence level. We also synthesize a typical 3-week learning schedule to highlight key experiences. On average, the interview preparation involves 6-hour problem practice per day based on LeetCode. Students have different learning focuses at the pre and later stages, and they adjust their learning strategy accordingly. For example, they regarded LeetCode as both important and urgent, therefore they do it the whole time. For other tasks like behavioral question preparation, they think it's important but less urgent and won't start until the interview is imminent. The stress level also starts to soar as the interview is approaching, and students' confidence level drops as they hit hard questions. During the creating session, participants were given 18 types of CS Note components, such as test cases pseudocode. The task is to create a handout to help a peer learn a node type of technical questions. The session allows us to identify node types that CS students deem to be the most helpful, which include algorithm explanation, thinking process, and tricks and mistakes. Synthesizing the key results from the Discover phase, we are now ready to define the problem and the opportunity space, the specific learners, their learning context, and the learning needs, based on what we come up with high-level criteria to ground our design.
From the research, we found that the technical interview preparation is heavily platform-based, tedious, stressful, and lack of reflective components. So how can we help enhance this experience with notes, the strategy that most people use? Specifically, how may we help CS students have a more personalized and less stressful learning experience through reflective note-taking and reviewing? Let's take a look at our personas. With the personas, we want to show our target users' needs and pain points. The first target user, Jack, is a junior developer at a company, and now he wants to switch jobs. So he's been practicing frequently tested questions from his dream company. But because he has a full-time job, the time constraints have made his learning very inefficient. Our next target user, May, she's a sophomore computer science student. She has no experience with working as a software engineer, yet she did get an interview invite from a tech company. She's very excited about this opportunity, but she doesn't know what to expect in the interview, and also nervous that her knowledge is not sufficient for the job. So if you think about the learning experience during the preparation, the users need to be able to accumulate knowledge in the early stage and then be able to review and find gaps in the later stage. From our target users, we're able to list out specific needs, such as they need to familiarize with the frequently tested questions in the actual interview, and some pain points, such as it is hard for them to keep track of their learning progress. We also distilled a user journey from the research, and we want to use this to show our opportunity space. The blue bar in the graph indicates confidence level, and the red bar indicates stress level. For a typical user, their confidence and stress level starts off low, and as the user accumulates more knowledge, their confidence level builds up. But as the interview date approaches, their bad practice results can mean a drop in confidence and a raise in their stress. That's where we see the opportunity to help. We hope that with our solution, users can get more confident with their preparation. Some key design criteria also emerged from the research for us to follow. So the tool that we're designing needs to be constructive, retrievable, lightweight, and seamless across platforms. With that, we went into some ideation sessions and brainstormed some ideas for the final design. After some discussion, we have decided to go with a cross-platform application that supports guided note-taking and promotes note reviewing by converting personal notes to self-testing options. For the note-taking part, we integrated with the most popular practice platform, LeetCode, so the users can have a quick way to generate guided question-based notes from there. With all the notes and questions, we want the users to self-evaluate their perspective of familiarity and importance. This will be the main metrics for the system to help users with their study plan and for the users to keep track of their learning status. Now for the self-testing functions. As we learned from the research, the three most important components to understand in the question are topics, algorithm, and coding. We designed three different testing methods to help users efficiently review and learn about them. Aimed to topics and algorithm review, we used flashcard and voice recording for users to quickly go through the materials. And for the programming review, we introduced Parsons problem, which is a way to rearrange code snippets and try to get it work. It is also an easier and efficient way to strengthen users' coding knowledge. Since we have the concept ready, we made them into a clickable prototype with wireframes to conduct the initial round of user testing. In these user testing sessions, we want to find out users' reaction to the overall concept, evaluate the system's overall usability, and to find potential improvements. We conducted 5 rounds of remote usability testing with 5 CS students, and with each student, we asked them to complete 3 tasks regarding note creation, notes review, and notes quiz. By the end of each user testing session, we ask the users to complete a SAS survey for us to get some quantitative data. Now, as you can see here, the task completion rate is 100%, and we had an average SAS score of 68. This indicated that there are a lot of improvements that we can make with the design. From users' feedback, we have found several directions for design iteration, such as the need for consistency with different platforms. Now let's dive into the detailed final design. We'll be focusing on the main flows and functionality through the detailed design session. The first functionality that we want to introduce is the note creator. As you recall, it is the function where users can capture their key learnings. The note creator is based off of the different problems on LeetCode, the most popular practice platform among students. Because we wanted to make it lightweight, this function is in the form of a Chrome extension. So when a user is working on a LeetCode problem, they can click on the Chrome extension to get the note creator. The note creator is then popped up on the screen, and it is generated based on the question that the user is working on. It will add contextual information such as the title and description to the note. Here, users will have the chance to rate the importance level and familiarity level that they feel about the problem. These self-evaluated metrics will later be used by the user to filter out the notes and also to help the system determine what to recommend to the user in a quiz. And when the user clicks on the add button here, they can expect to see a creator that they can put customized notes entries in it. Now we associate each note here with a note type. These are the three most important types that users would want to add to a question note. So these are algorithm explanations, tricks and mistakes, and thinking process. Once the user selects a type, they can add their personal annotations in it. Here I want to introduce the tools that we have to assist the user's creation. The first tool is the capture tool, as we understand that users rely on markups around real code. When a user uses this tool, they will capture a space on the website, just like taking a screenshot, and the user can add any markups on the screenshot as well. The picture is then saved to the editor, and when the user clicks on save, it will become a note entry. Another tool that we want to highlight here is the picture uploader, which allows for a seamless transition between the mobile app and the web app. As we observe that users use a lot of handwriting when trying to note down their thinking process, and we want to help making saving the content easy. So when a user uses this function, they'll get a notification from the mobile app to take a picture on the phone. And once the picture is taken, the picture will get uploaded to the note entry that the user is working on. We hope that with these tools and guided structure, users will find this process lightweight and low effort. Once the user have the question-based notes, they will have a centralized place to view notes and take quizzes based on them. The same functionalities are available for users on mobile apps, and the mobile apps will support the on-the-go kind of user scenarios. Users can easily go to the Note Center from the Note Creator by clicking the View All button. Once the user reaches the Note Center, they will be able to view all the notes they have created in one place. Users also have the ability to search and filter out notes by specific criteria. All the notes that are showing on the screen are available for users to start a quiz review, and you can expect the same quiz entry from the mobile app. Now let's dive a little deeper into the quiz functionality. Users can navigate to the quiz center, which is another entry point to go into quizzes. We focused a lot on the system recommendation here. Users will see the recommended lists based on their familiarity and confidence rating to the questions, their past performance, and their upcoming interview schedules. But users can also select the list that they have made themselves. We allow multiple selections here, so users can select multiple lists to start from here. The entry point is also available on the mobile app. Now I'm going to talk in depth about how the quiz method works. When the user clicks on Start a Quiz, they will have the chance to select what method they want. The first method is a flashcard algorithm review. Users will be presented with the question and its description. They can click on the card to see their own notes to determine if they get the questions right. Here, users will have another chance to self-evaluate. Because we're not judging if the user get the questions right or wrong, they are the ones to evaluate themselves. We ask them to rate their familiarity level after each question, and the new rating will give the system information on the future quiz recommendation. The interaction is pretty similar on the mobile app. Users can swipe to see other questions and they can tap on the card to see explanations. They can also rate at the end of each question. The next quiz method is the topic review, which is also a flashcard format, and users can see the explanation of each topic from their trusted source. We also provide a list of questions related to the topic that they are reviewing, and they can save for later practice or simply go to the platform LeetCode website to practice. On the mobile app, users have the same information presented to them. The next one is the code review, which is in the format of a Parsons problem. Again, it is an exercise that asks users to rearrange a set of code snippets to get the program right. On web application, the interaction is pretty straightforward. Users can just drag the code snippets to the editor. For mobile app, we change the interaction into a reorder. Users will drag the code snippets to rearrange their orders. Last but not least, I want to talk about the mock interview testing method. Through our research, we realized that users want more randomized practice towards the later stage of preparation. So with the mock interview, it will generate a randomized quiz from selected lists with mixed methods. As you remember, we have a voice recording quiz method. But from our user feedback sessions, we recognize that the voice recording feature does not have a frequent use case. Users express the idea that they do not want to, nor have the energy to speak for a really long time, but they also recognize that this is a great way to help them be prepared for their actual interview. So I want to surface this functionality here in a mock interview. Users can expect to record their thinking process for a maximum of 2 questions. We also added an option for users to save their recording as a note entry to their question note so that it provides another way for users to review the algorithm by listening to the recordings. Of course, user can have the same experience on their phone. Users can also access the voice recording functionality with the notes viewing mode. On the web app, when the user double-clicks on the question note, they can enter the viewing mode. And from there, they can use voice to record or scroll down to access their saved recording. And the interaction is consistent throughout 2 platforms. That is the end of the detailed design walkthrough. Now for our next steps, since we have the high fidelity designs and we made them into click-through prototypes, we want to use them into our future testing. We have attached the final testing plan in the attachment folder so you can view them later. We have planned another usability testing session. For these sessions, we plan to recruit 8 participants. The main goal is to still gauge the overall usability of the system with the redesign and find potential improvements. Specifically, we want to focus on users' intention to use the system, their satisfaction and perceived benefits, and also the system's learnability and efficiency. Similar to the first round of testing, this is still a cognitive walkthrough with the 3 main tasks. This time, we want to survey the user's confidence level and stress level after each task, and also collect survey at the end of all tasks in order to compare with the previous round of testing. Now, through our project, we have learned a few things, and we wanted to take this opportunity to reflect our learnings with you. The first thing that we learned is that it's important to have a focal point to start. This is related to the intended scope versus the real project scope. So initially for this project, we wanted to explore design opportunities for an effective note-taking tool. But this intended scope is obviously too big to be executable. By picking note-taking in computer science, we could specify the learner and consequently the learning context to drive forward the momentum. After finishing the design, we realized many features could be expanded to other subjects, and the current results provide a good basis to conceive the bigger scope. And the next thing that we learned is how to design for daily learning behavior. This is a challenge that we faced with they don't know what they want to do type of feature. As we're designing for how people should learn, it entails a challenge that people don't really know what features to expect. To provide features that will really facilitate people's learning goal and fit into their original learning habits, it is important to conduct both primary and secondary research to ensure the proposed solution could provide real benefits and elicit a high intention to use. And that is the end of our project. So in our attachments, we have included some files on our comparative analysis, the interview protocol, our lit review, the participatory design materials, 2 rounds of user testing plans, the midterm presentation slides, and the survey, and also the design files with the clickable prototypes. And we wanted to say a special thanks to our advisor, Bessie, for supporting us throughout the 2 semesters of doing this project. Thanks for listening to our presentation. And if you have any questions regarding anything in our project, please feel free to contact us for more details.